Good morning all. Welcome to lecture 7 of unit 3. Today we are going to discuss about avalanche photodiodes. So the introduction of this diode is performance of avalanche photodiode depends upon the efficiency. So efficiency is nothing but it converts light energy into electrical signal. So the principle of APD is to design and operate in reverse bias condition, and photoelectric effect is the principle behind it. So photoelectric effect means when the photons are incident on a material, electrons are ejected out. So avalanche photodiode is nothing but it's having high gain due to avalanche multiplication effect, increased noise. Silicon has high gain but low noise, whereas silicon, indium, gallium arsenide avalanche photodiode is often used, which is shown in the figure. So EPDs have high resistivity p-doped layer, which increases electric field across absorbing region. High energy electron hole pairs ionize other sites to multiply the current and leads to greater sensitivity. So structure consists of APDs internally multiply the primary photocurrent before it enters into the following circuitry. In order to carrier multiplication takes place, the photo-generated carriers must travel along high field region. In this high field region, photo-generated electrons and holes gain enough energy to ionize bound electrons in the valency band upon colliding with them. This multiplication is known as impact ionization, and the newly created carriers in the presence of high electric field results in more ionization called as avalanche effect. And the responsivity of APD is nothing but the multiplication factor, which is also called as current gain. M for all carriers generated in the photodiode defined as M is equal to IM by IP, where IM is the average value of the total multiplied output current and IP is the primary photocurrent. And the responsivity of APD can be calculated by considering the current gain as eta q by h nu into m, which is also can be called as r naught m. So earlier we have seen the silicon APDs. Now here we can have the multiple layer of indium gallium arsenide APDs, separate absorption and multiplication APDs. So in gallium arsenide APD superlattice structure, the multiplication region is composed of several layers of indium, aluminum, gallium arsenide quantum wells separated by indium, aluminum arsenide barrier layers. So the one was used made up of silicon, and here it is made up of gallium arsenide. So what are the merits of APDs are? It can be used as avalanche photo detector. It has large gain, greater level of sensitivity and high speed. Whereas the demerits are much higher operating voltage is required than the pin diode, much higher level of noise, output is not linear, requires high reverse bias for operation, not as widely used due to low reliability. And the applications of these APDs are level of gain is of importance for high voltage requirement, large range finders, fast receiver modules for data communications, high speed laser scanner, 2D barcode reader, and speed gun. So in this class, in the earlier class, we have discussed about pin diode and acting as pin detector. In this class, we have discussed about APD diode and how it acts as APD detector, avalanche photo detector. Thank you.